to homogeneous nonlinear equations. So just a quick note, previously, we used homogeneous to describe certain linear equations. So previously we used homogeneous to describe linear equations. Of the form y prime plus p of xy is equal to 0. And this cannot be generalized to nonlinear equations. So this will be a completely different version of homogeneous. So we will now look at a completely different definition for homogeneous. So a nonlinear homogeneous equation y prime equals f of xy can be written in the form y prime equals q of y over x, right? Where q is just a function of one variable. So for an example of a function in x and y that can be written in this form, f of x comma y equaling y to the fourth over x to the fourth minus 2 sine of y over x. This is y over x raised to the fourth minus 2 times sine of y over x. And therefore we could take q of, I'm going to use u because we'll use it later, to be u to the fourth minus 2 sine of u, then we would have q of y over x is the same as our f of x, y. So the question, why is it useful for equations to be written in this form? So recall to transform a nonlinear equation into a separable equation, we wanted f of x comma u times y1 to be written in the form of q of u times y1 prime. And it turns out if we have a homogeneous nonlinear equation, then we can pick our y1 just to be x. So if we have a homogeneous nonlinear equation, then we can pick y1 of x equals x. In doing so, what we would have then is, we'll call it f of x times ux would be equal to a q of y over x, so a q of ux over x, which is just q of u. And in this case, then, this is q of u times 1, better known as q of u times y1 prime, or also known as q of u times y1 prime. So if we are in this situation, it's very quick to then rearrange so we have a separable equation. So for example, let's consider the equation y prime is equal to y over x plus e to the y over x. So again, note that this right here is q of y over x, where q of u is u plus e to the u. So now let's go ahead and set y1 to be x. And we assume that y equals u times y1, otherwise known as u times x, is a solution. We have y prime is equal to u prime x plus u, and this should be equal to y over x, so u times x over x plus e to the u times x over x. So again, this part here is just our y over x plus e to the y over x. This therefore simplifies to u prime x plus u is equal to u plus e to the u, or u prime x is equal to e to the u. And we get e to the negative u prime is equal to 1 over x. At this point, we can integrate on both sides. So on the left, we have the integral of e to the negative u du is equal to the integral of 1 over x dx. And integrating e to the negative u becomes negative e to the negative u. On the right-hand side, we have the natural log of the absolute value of x plus c. So we have e to the negative u is equal to negative natural log of the absolute value of x plus c. Negative u is therefore equal to the natural log of negative natural log of the absolute value of x plus c. And u is equal to negative natural log of the absolute value of x plus c. At this point, then, we can go back to our beginning, and our solution should be y is equal to, we had u times y1, or u times x. And so we have y is equal to negative x times the natural log of negative natural log of the absolute value of x plus c. So this is how we can go about solving very specific nonlinear equations. So if you notice, they take this homogeneous form where we have it as a function of y over x. Then we can go ahead and use essentially a variation of parameters where y1 is just x. All right, that is it for your transforming nonlinear equations into separable equations.